Now, as we start chapter 9, we're going to look at probability. And we remember we had some general background in our flip classroom video, but here they're going to ask us some specific questions. And we're going to look at protocol, strategy for getting answers. Now, a standard die is rolled. Find the probability that the number rolled is greater than 0. Well, there is no 0 on a die, so it has to be greater than 0 every time you roll it. So this is going to be probability of 1, and we can think of that as, in a sense, 100%. Or in decimal form, 1.0. So we're starting off easy, but again, some critical thinking. In number 2, as we look at it, and again, you have to read it, you're going to have a 3-color spinner. So there's a spinner there. And let's see, this is going to be red, blue, and yellow. And then you have a 6-sided die. I think you all know what that looks like here. With the 6 numbers, dots on it. Now, what they're asking, and this is a little bit tedious, and I'm going to, well, I'll leave that there. I think I have room. Identify the sample space. Well, the numbers on this will be 1 through 6. And then you're going to have one of these colors possible. So there's 3 colors. So setting this up, it'll be 1, 1, 1, 2, 2, 2, because there are 3 colors, 3, 3, 3, and I have room here, 4, 4, 4, and just setting it up. Again, you want to develop some sort of strategy. Now, you could have a 1 with a red, and then a yellow, and then a blue. And you're going to do that now for each of these. Take a moment. So something like this. Now you might say, how many should you have here? Well, 6 possibilities here and 3 possibilities here. So 3 times 6 is 18. There'll be 18 that you would need to write as your sample space. Now, the probability of getting any one of these is 1 out of 18. All right, let's go on. Now, for number 3, someone's going out, going to have a salad. Now, we have a choice of olives and mushrooms. We can also add pepperoni and bacon. And we can also have a choice of French dressing or a vinaigrette. So what would be the sample space, the sample field for combinations? Well, there are 2 here, 2 here, and 2 here. So 2 times 2 times 2, there's going to be 8 possibilities. But how do you set it up? Well, a suggestion would be O, right? You can have the O. Then you can have a P with it. And you could have an F. Then you would have O, P. Then you could choose a V. Then you could do the O with the B and then an F. Then the O with a B and a V. So this gives you, using the O, your possible combinations. Now, we're going to let you do the second row and see what you come up with. But this time, you're going to choose the M and see if you can get the other choices. So hopefully something like that. In fact, note that the second row, the only thing different is instead of an O being there, you now have the M. But the choices are basically the same. Again, we said there would be 8, and we have 8 different combinations. So getting any one of these would be 1 out of 8. All right, let's go on. Now, as we look at example 4, it says a newspaper company classifies its customers by gender and location of residence. The research department has gathered data from the random sample of this. So what does this stand for? Well, the sum of all of these numbers. So we have the total 1676. Now residents, apartments, dorms with parents, etc. What is the probability that a customer is female? Well, again, you look at the data. There's your genders, male, female. And what would you do? Well, you're going to add up your total of females. And I've done this for you. You get 762. So you now have your total sample space, and the interested portion of that sample space would be a female. So the ratio would be then 762. Now here they want the answer as a fraction or a decimal rounded to 4 decimal places. Now they didn't specifically say simplify the fraction. So theoretically you could just put this in there or put that into your calculator. But you notice you could take a 2 out of each one of these if they were interested at 381 over 838. And when you put that into a decimal, that's 0.04546 5, and you're rounding it to 4 decimal places. This is critical. So the 5th decimal place is a 5. We're going to drop that and make this 6 a 7. Now, again, on a test, you're writing out all of this information. You don't have to copy the chart. But if you have this, if you had this, if you had that, and then depending what you put in, I can give partial credit or in some cases even full credit. They have an algorithm that they follow to match answers, but the teacher can look at things and give partial credit. All right, let's go on. Now, as we go on to number 5, I'd like you over here where I have this one, create this little chart. And you're going to take a moment as we pause it. And on the top, you're going to put 1 through 6. And then on the side, 1 through 6. Just sketch it out. I have it in my booklet as well. Now, within this chart, and this is one die, and this is another die, we're going to roll them, and what would be the sum of the dies? Well, 1 plus 1 is 2, and then 2 plus 1 is 3, and so on. And then 1 and 2 is 3, 2 and 3 is 4, 1 and 3 is 4, 3 and 2 is 5, and so on. And it follows a pattern, interestingly. So what we've gotten here is the total sample space of when you roll 2 die. There's 6 and a 6, so there's 36 possible outcomes. Now, some outcomes are repeated. This is a good little tool. Now, you might be able to do it conceptually in your mind, but it's also nice to have a little table that you can use. So, for instance, what is the probability of rolling a 2 on a standard pair of 6-sided dice? Well, you look at your chart. How often is it 2? Well, it's once only out of a total of 36. Now, coming up in another example, I think on the next page will be rolling a 3. Well, there's 2 ways to roll a 3. We won't have this chart available, but you'll have it in your book, your little notebook here. That would be 2 out of 36 or 1 out of 18. Well, we're here. What's the probability of rolling a 7? Well, there it is. 1, 2, 3, 4, 5, 6. That is 6 out of 36, which is 1 out of 6. So 7 is the most common. Now, which are the rare rolls of the dice? Well, getting a 2. They call that snake eyes in that lingo there. Rolling a 12. Well, there'd be a 6 and a 6, so these are called box cards. Boxcars, like, I don't know where that comes from, but anyway, that's about what I know. But having a chart like this, very useful in dealing with probability. What's the probability is going to be less than 4 and greater than 9? Well, you just count, and it works out really nicely. All right, let's go on to our next one. Now, often in these, you're asked to do some kind of tabulation, here's a table of people that are on campus, and in regard to the survey, they were asked whether they would vote in the upcoming election. Well, for yes, males, females.
I'm not sure.
And for no is this, and then for undecided. Okay. So again, you might want to consider what is your total population here. Well, I did some calculations for you, but you would have to do this normally. And it's 112. I added them all up. Now, they're asking you, what is the probability that the upcoming election of people who would not vote? Well, the only ones you could choose here are the no's, which would be 44. Now here they are asking as you express your fraction in lowest terms. So we can take a 4 out of there, which would be 11, and we could take a 4 out of there, which is 28. So that would be an acceptable answer, or a decimal rounded to the nearest millionth. All right, when you put that in there, you get 392857149. Wow. And millionth. Well, how many places are a millionth? Well, it's 6 places. 1, 2, 3, 4, 5, 6. You go to the 7th place, it's a 1. So you're just going to drop all of this, and that would be the answer. Now, if you can express it as a fraction, that's so much easier, because here, if you're just off by one little number, they count it wrong. But here, it's kind of an easier way to do it, but you have the option. All right, let's go on. Now, for number 7, again, you'd look at your chart of the dice, and how often would you get a 3? Well, again, these were some basic elementary ones. There were 2 possibilities, so 2 out of 36, which is 1 out of 18. And you can figure out the decimal form, but putting it in this fashion is the easiest way. All right, let's go on to our last one. And here we're asked to, again, read it, of course. And then what are they asking? Well, there are 295 chips, and they're numbered 1 through 295. What is the probability of reaching into the box randomly and drawing a chip that the number is smaller than 102? Well, how many would that be? Well, they're numbered. How many are there before 102? Well, 101 out of 295. And that one, what are they asking here? Simplified fraction. Well, 101 is prime, so you could use that. Or in its decimal form, I did this one also, we get 0.34237228. So they want 4 decimal places. So 1, 2, 3, 4. The 5th decimal place is a 7. So we'll drop those and make this 3 a 4. Okay, now we only have 3 lessons left. So again, you're staying up to date, doing your practice, and be sure you're asking questions.